Lesson 18 in Module 7 is on applications of the Pythagorean Theorem. So how are we going to use the Pythagorean Theorem in real life? Okay, so we're going to be maybe pulling in some other things that we've been practicing, but if we're missing a side length to a right triangle, or if we're looking to see if something's a right triangle, we can always use our Pythagorean Theorem. So it says the area, and actually let me pause for a second. Remember our Pythagorean Theorem is a to the second power plus b to the second power equals c to the second power. A squared plus b squared equals c squared. Remember c. That is our longest side, our hypotenuse. Okay, so looking at this example, excuse me, the area of a right triangle is shown below is 26 and 46 hundredths square inches, the area of that right triangle. Okay, and it's looking for the perimeter. Perimeter, remember, is the distance around it. So honestly, it really seems like we do not have enough information. But we're talking about area here. It's a right triangle. So if I think area, maybe think Pythagorean Theorem, maybe we can come up with something. Let's start with the area idea. The area of a triangle is 1/2 the base times the height, or multiplying by the half, the same thing as dividing by 2. So base times height divided by 2. So it tells us what the area is. So I can take this area and I can plug it in right here. And I can say 26.46 equals, well, remember when we're looking for looking for missing side length, the longest side across the right angle is C. The two sides that make up the right angle are the legs. They're A and B. So I can say that maybe this is, I'm sorry, the two sides that make up, there are A and B, but they're also the base and the height. Okay? I like it that we come up with all these different variables to describe things, right? So the base and height, also you find them by finding the right angle. So it doesn't matter if you think this is the height or the base. I'll say it's the base. Okay, so this is the height. So I'm going to go 6.3 times h divided by 2. And now I'm going to solve for h. Now there's different ways you can do this. You can divide this out. I am going to be like, well, I'm solving for h. I'm going to get rid of this dividing by 2 here, and I do that by multiplying by 2. Remember, we can do whatever we want as long as we do it to both sides. So if you go 2 times 26.46, you get 52.92 equals, and then remember, 2 on the top, 2 on the bottom, they cancel out to a bunch of ones. We're left with 6.3 times h, or b if that's a variability did. Now, we're still solving for my h here, so my other side length. So I'm going to have 6.3 times h. I'm going to undo multiplying by dividing. I'm going to divide by 6.3. Whatever I do to one side, I got to do to the other. 6.3 divided by 6.3 is 1h. And then just grab your calculator, excuse me, 52.92 divided by 6.3 is 8.4. 8.4. So we get two of the sides of our right triangle here, 6.3 and 8.4. So even though it doesn't seem like we have enough information, I've now found two sides to my triangle. Can I find the third side? Because my ultimate goal is to find perimeter. Perimeter is the distance around the outside. Sure. So I use my Pythagorean theorem, a squared plus b squared is equal to c squared. And remember, in this case, the sides that make up the right angle are my legs. They're my A and B. And then always we have C, which is across from the right angle. So I can say that like this is 6.3 squared plus 8.4 squared. If you switch those around, remember it really doesn't matter because we're adding. We can add in any order. And then I just type that in my calculator. 6.3 to the second power. 6.3 times 6.3 is 39.69 plus 8.4 squared is 70.56 equal to c squared. And then I add them together. And I get 110.25 equals c squared. Now again, that equals c squared. We want to know what c is. So what number times itself equals this? Well, we have to undo the squaring. So I undo squaring by taking the square root. If you take a square root of a number squared, well, they cancel out. We're left to just c. Now, I'm guessing this is the exact answer right here. I might probably going to approximate it, take the second square root, so second x squared in my calculator. Oh, I get 10.5. Okay, so this side here is 10.5. All right, so always make sure, because we've done a lot of work here, that we're answering the question being asked. They asked us, what's the perimeter? Well, perimeter is the distance around the outside, so all we have to do is add these up. 6.3 plus 8.4 plus 10.5. Calculator. I mean, you can do it by him if you want, but you don't have to. And I get 25.2. And those are just inches because we're not saying how many squares are needed to cover it. We're not saying how many cubes need to fill it. We can just measure something. Okay. So again, using other information we know about triangles will sometimes help us find the answer to a question like, what is the perimeter? All right, so let's look at one more example here. Typical ratio of length to width in a TV that is used to produce televisions is 4:3. Okay, so whatever, like the length is 4 times and the width is 3 times whatever that certain number is. Okay, it says a TV with length 20 inches and 15 inches, for example, had sides in a 4:3 ratio, as does any TV with length 4x and width 3x. Okay, I'm going to show you that just real quick here. If I had 20 over 15, 5 goes into both of them. Okay, so if I divide 20 by 5, I get 4. If I divide 15 by 5, guess what I get? 3. This is what they're talking about in a 4:3 ratio. Okay, the important thing you need to remember is right here, 4x and 3x. We're going to come back to that in a second. So this one says, what is the advertised size of a TV with length 20 inches and width 15 inches? When they tell you the size of the TV, 55-inch TV, 85-inch TV, whatever it is, they're telling you the diagonal across. Okay, so if we know our length here is 20 and our width is 15, and this has to be a right angle, right? Otherwise the TV is going to be kind of wonky. We can find out what C is using our Pythagorean theorem. 20 squared plus 15 squared equals C squared. So that's 20 times 20 is 400. 15 times 15 is 225. And that equals C squared. And then we just keep going with it, right? That's 625 equals C squared. And then we take the square root of each side. And when you grab your calculator, and again, if you have any issues with your calculator, make sure you ask me. When you take the square root of 625, we get 25. All right. This is, and I'm gonna write this in just because I want you guys to see that. It says, since the TV has a diagonal of 25 inches, then it is a 25-inch TV. Okay, so when you see that, again, a 25-inch TV, a 70-inch TV, whatever, it's talking about the diagonal. Okay, so now let's use that knowledge to deal with those ratios again. 4x and 3x. When you divide the length by width, it should divide out to, or simplify to 4/3. Okay, because this one says a 42-inch TV was given to your family. What are the length and width? So pay attention to this. Okay, excuse me. Told you that length to width is 4x and 3x. Length of 4x, width of 3x. Okay. Whatever x is, the length's going to be 4 times that. Whatever width is, sorry, not width. Whatever that standard number is there, the width is going to be 3 times that. So what we do, because we have a TV here, and it tells us it's a 42-inch TV, so our diagonal is 42 inches. We need to know the length, 4x, and the width. Okay, just use 4x and 3x. So we can figure out what this is because remember, this has to be C. So 4x, that whole thing squared, plus 3x, that whole thing squared, has to equal 42 squared. This, remember, is 4 to the second, x to the second. This is 3 to the second, x to the second, because it's multiplying in here. Those exponent rules coming back. So 4 squared is 16 times x squared, plus 3 squared is 9 times x squared, equals 42 to the second power, 1,764. Like terms, we add them together. That's 25x squared equals 1,764. Back to solving equations again. Divide both sides by 25. 25 divided by 25 is 1x squared. We divide 1,764 by 25, we get 70.56. And then we take the square root to get what x is. And it works out to be 8.4. Okay? Now, just to finish up here, what is the length and width of the measurements on TV? Well, the length is 4 times whatever x is, 8.4. So if you go 4 times 8.4, you get 33.6 inches. Hopefully I did that right. And 3 times 8.4 is 25.2 inches. Okay, so when we have a 42-inch TV, its actual length is 33.6 and its width is 25.2. So check those. Check those are right. Okay, so what does that mean? We're like, is 33.6 squared plus 25.2 squared? Does that equal our diagonal? 42-inch squared. So I'm just going to type this on a calculator. 33.6 squared plus 25.2 squared. That equals 1,779.21. And I think I typed something in incorrectly, so don't write that down. Sorry. I put 25.5. It's 25.2. That's what I get for hustling. I get 1,764. And if I type 42 squared, I get 1,764. So it works. Last question. We've got a TV, we've got a stand that's 30 inches in length. Will it fit? No. Okay. No, I'm just going to say no. The length of the TV is too long. Because our length is 33.6 and this one is only 30 inches. Okay, so again, learn something new about TVs. When you have a 42-inch TV or whatever, that's the measure of the diagonal. And knowing what we know about the Pythagorean Theorem and right triangles, we can use that information using our 4x and 3x ratio to find the actual length and width of TVs.